All right, pre-calculus. We're into chapter 2. This one is solving equations, kind of back to more maybe normal algebra for you. The first part we're going to have is 2-1 solving equations, just a few examples. A lot of these should be review. We're going to go through some fractions, some quadratics, things like that you've done before. Then we'll get into 2-2, which has a few new things. But they all follow the same patterns that we've learned. How do we do an inverse function to solve an equation? So based on things we've done before. All right, let's start with 2-1. A few quick examples on this. So we've seen things like this before with fractions. We want to get rid of all the fractions first. Same thing we did with complex fractions, get rid of all those little denominators. Same thing we're going to do here. So big thing here, equal sign. So with an equal sign, we know we can balance something by doing the same thing on both sides. To get rid of fractions, fraction means divide. So we are going to multiply everything to get rid of all these. And we need a common denominator. So always try to clear fractions first. Okay? Clear out your fractions. Multiply by we'll try to find the least common denominator, the LCD. Any common denominator will work. With numbers, we got 3, we got 6, we got 4. All of those go into 12 would be the one. You could use 24 and you'd have bigger numbers left in the equation, but our idea is to make this into whole numbers so we don't have fractions anymore. So 12 is what all those go into. Now we have to multiply everything here by 12. That doesn't mean we have to do a lot of distribution by 12 and division. Remember, every one of these should reduce with 12. So if we do first one times 12, reduce, and we're going to have 4 left. The 3x plus 1 is still there waiting to be multiplied. Okay, the next one times 12. So the 6 and the 12 reduce to a 2. It's minus 2 times the x minus 4. So remember, you're reducing from the denominator, and what's left you multiply in the numerator. So equals over here times 12. That one's going to get 3 times 1. Okay, so that numerator times the reduced common denominator reduced by the denominator that's there. So we end up with hopefully a pretty simple equation back from Algebra 1. We have all whole numbers now. We need to distribute combined like terms and solve. So 12x plus 4 minus 2x plus, don't forget about that, plus 8 equals 3. And what do we have? 10x, that's going to be plus 12 equals 3. And we end up with negative 9/10 is our answer. Okay, so clear out fractions, make a common denominator, kind of like we did with the complex fractions, and you should have a whole number equation left to solve. Next one, x squared equals 4x. This one's more about what not to do. So x squared equals 4x. It is tempting to divide by x, divide by x. X equals 4. Oh no, we've lost something. There's another answer to this one. What we want to remember is do not divide by a variable. Okay, don't divide by that variable because we lost an answer. This is where we went wrong. So instead, I'm going to see this come up again and again this year. If we can divide, we can subtract. And if it's equal to 0, what we've got is a factoring problem. So instead of dividing, subtract and factor. So this is x times x minus 4 equals 0. Remember, the whole point of factoring is take something complicated, make it into easy equations, but there's just 2 of them. X equals 0, and I guess x minus 4 equals 0, but you can solve that in your head and say x equals 4. So here's the one we lost. We lost 0. That is a true solution to this. It's because when we divided by x, we forgot you can't divide by 0, so we lost that answer. So this one does have 2 solutions, 0 and 4. Do not divide by that variable, okay? That is where you're going to lose possible solutions. Next, we have quadratics here. First one looks kind of normal, x squared plus 6x equals 4. With quadratics, if we can factor like the last one, that's great. So practice your factoring. You can get those answers easily. This one, remember, to factor, we do need equal to 0. So get that equal to 0. It doesn't factor. So always try that first. Doesn't factor what's left for us. Remember, this is a quadratic. Be nice to have a formula to use. That is the quadratic formula that we're going to use on this. So remember your quadratic formula. Solve for x. We have an a, b, and c are the coefficients. Negative b plus or minus square root of b squared minus 4ac all over 2a. You've done that since Algebra 1. You have to know that formula. If you can't factor, that's a way to solve this. You can even use this if it does factor. So how do we put everything in? In this one, a is 1, b is 6, c is negative 4, and you've done this, like I said, since Algebra 1, so just quickly through this. The opposite of b, so negative 6, plus or minus, we're going to have two answers. Square root of b squared, I'm just going to put in 36. Do that in your head. Remember, negative squared are still positive. Minus 4 times a is 1 and c is negative 4. Careful with negatives through this. All over 2 times a, which is 1. So make sure you got the order of operations right here. We've got to figure out what's inside this square root. So 36 minus 4 times 1 times negative 4 makes it plus 16. That ends up with 52. Careful with the arithmetic through here. It's all steps of arithmetic. All right. We do need to reduce, but remember, this 52 is trapped inside of a radical, and the 2 to reduce has to reduce both parts here. It's got to reduce both the minus 6 and whatever comes from this root 52. But you can't reduce inside of square root by outside of square root. So simplify the square root first. So we'll keep all this here. Root 52, that is 4 times 13, so it ends up as 2 root 13. 2 times 2 times 13 if you break that down. Okay, pair of 2's. Now we can reduce both terms, both of those reduce by 2, and we end up with negative 3 plus or minus 1 root 13 over 1. So there is our solution for x. Okay, reduce the radical, then try to reduce, or simplify the radical, then try to reduce both parts of the fraction. They both have to reduce. All right, next one is a quadratic. It's got an x that's being squared. Now, some of you might want to do things like this. You might want to FOIL this out. X squared plus 4x plus 4 plus 5 equals 25. Combine like terms, x squared plus 4x, we got equals 25, subtract it over, 4 and 5 is 9, subtract it over, and we get minus 16. Then we try to factor. Now we have to use quadratic formula, and this is what's called the long way of doing this. Don't do that. The key here is that there is only a single variable on this side. There's only one place where you see an x. It is inside something squared. That's called a pure quadratic. Now, when you just have one variable that's squared, you can square root to get rid of it sometime. So that's what we're going to do. If you just see this parentheses, we're going to hear this a lot. First, isolate the important stuff. X plus 2 squared equals 20. Subtract that 5. Now we can get rid of the outside to inside. Now we're going to square root. We get x plus 2 equals square root of 20. You put the square root in there. So we got this plus or minus. And 20 breaks down into 2 root 5. Be able to simplify those radicals pretty quickly. And now all you have to do is subtract. So x equals, I'm going to put it first, negative 2 plus or minus 2 root 5. Remember, this is two answers, negative 2 plus 2 root 5 and negative 2 minus 2 root 5. All right, there are some quick examples from 2-1. That should get you started on all of those. A lot of review on this page, things you've done before. All right, keep going with 2-2. So some radical equations, equations with different exponents we're going to see, or radicals, and rational equations we're going to see a little bit right at the end. Maybe some combinations. So first, this is really just all different kinds of factoring that'll show up here. Let's take a look at this first one. First one looks like a trinomial. It is equal to 0. First option on these, especially with the whole number exponents here, is try to factor it. Okay, and this is one that we went over back in chapter 0, a trinomial, and the key is take a look at the exponents. The relationship there is double. okay, or a 2-to-1 ratio. So that means we can do it like a quadratic. So we're going to factor this like a quadratic. But remember, the first term is not just going to be x times x, because we could have something like x minus 64, x minus 1 to make this happen. But the middle variable here is what we use, x cubed. There, it's factored. Okay. Now remember, the idea of factoring, when it's equal to 0, remember, factor, it only really helps if it equals 0, and that's what we have. So we use that 0 product property, and really we just make this into two equations. X cubed minus 64 equals 0, and x cubed minus 1 equals 0. Those should be pretty easy to solve. We got x cubed equals 64, and cubed, we can apply a cube root. That'll get rid of them. I'm going to talk about that more in the general sense in a little bit. But this is just x equals cube root of 64 is 4. Cube roots, odd roots, there is no plus or minus. Okay, it is just 4. Same thing over here. Now, some of you might have thought we can factor this more, which you could, but look how easy it is to solve without factoring. Add the 1, cube root, and cube root of 1 is 1. Okay. If you would have factored this more, we would have gotten x minus 1 times it's x squared plus x plus 1. Okay, maybe we want to try that. Well, here is x equals 1. That's the only answer. This one is a quadratic formula problem, and it will not have any answers in it. So when you have a cube, you don't need to factor it more. This factoring is really to help us reduce fractions. X cubed minus 1, when we're solving, that's easy enough to solve on its own. So we get 4 and 1. That one had two solutions, no plus or minus with a cube root, only even roots, like square root. Let's see another one. We're going to do some radical equations here. So 5x minus 1 inside of the square root minus 6 equals 1. Okay. Well, if we think through this, we know how to get rid of any term, use its inverse, like minus, we'll do a plus. Okay. Oh, what's the inverse of square root? We're going to square this sometime. Don't do it right away. Here's this thing we said on the other one. First thing I want you to think of is isolate the important term. Okay, the important term is root 5x minus 1. That's what we have to figure out how to get rid of. Add that 6 to the other side and we get 7. Isolate it first. Then you can apply any kind of big inverse operation that you want to do, and we can square both sides. So somewhere we're going to square, but get that term alone first. That makes this just come out as 5x minus 1. 7 squared is 49. And add 1, divide by 5. That's 50 divided by 5 is 10. Okay. So once we square it, it should turn into a problem pretty easy for us. But isolate that term first before you square it. Otherwise, you have two pieces in here. You got to square the entire side, okay, not individual parts. So try to isolate it first. So let's look at this one. It has more stuff to it. There's an x out here. Then there's this term that has a square root, also has a 2 next to it. And there's something over here. So again, the big thing here is a square root. So isolate the term. We're going to keep the 2 next to it. I'll show you what we do with that. 2 root 2x plus 1 equals, so to move the x, we got to do 2 minus x. Isolate this. Then we don't have to get rid of that 2. That would cause fractions. As long as the term is together, these are multiplied here. We can square, and you square the side, right? So square the entire side of the equation. When you do this, you have to square both parts, though, okay? Remember, if we have a times b squared, this is a squared times b squared. You distribute the squared over the multiplication problem. So 2 squared is 4 times, and the root squared is just the 2x plus 1. We get rid of that root. On the other side, we have to square, not individually, the entire side. To do that, we have to do 2 minus x times itself, 2 minus x. So it is not just 4 minus x squared. We get 4. We're going to get a minus 4x inside and a plus x squared. FOIL this out, okay, to make sure you have all the terms. That was easier to foil than trying to do that with this entire side with the square root. So now we end up with, let's see, 8x plus 4, 4 minus 4x plus x squared. That's just quadratic. It's just got like terms to combine. So let's make it equal to 0. So we can factor. We have to have equal to 0. X squared, subtract, we got minus 12x, subtract 4, we got 0. So this one factors into x times x minus 12. So x is 0, and 12 is what we have. Okay. Now there's actually one more step. There's a little problem with this. So we know just from Algebra 1 even, when we solve an equation, the numbers we get, solving means if we plug them in, it makes the equation true. Well, look what happens here. If we use the 0, and we do 0 plus 2 root, that'd be 0 plus 1 is just 1. Does that equal 2? Well, 0 plus square root of 1 is 1. 0 plus 2 equals 2. That works. Okay, that's good. 0 is a solution. Look what happens with 12. 12 plus 2 root. 2 12s and 1 is 25. Does that equal 2? Take a look at that. That's not 2. That's 12 plus 10. 2 times 5 is 22. It does not equal 2. 12 is not an actual solution. We didn't do anything wrong. You just have to pay attention for those. Remember, that's called an extraneous solution. It means it's not a solution. Okay. Now, the only answer to this one is x equals 0. That's all you have to tell me. You found all the solutions in 0. You don't have to tell me that 12 is extraneous. You just have to know not to put that in your answer. You have to check. Now, what caused that? The thing that caused it here is squaring both sides. There's a couple ways to explain this. The math behind it is squaring sides. Squaring as a function is not 1-to-1. That means it brings in more than one answer. So if you look at how we checked it down here, if this plus would have been a minus, we would have been okay. It would have been 2 equals 2. Basically, squaring both sides, we know it turns everything positive. Well, that means it ignores the difference between a plus and a minus. So it's ignoring that difference and gave us an answer, but that didn't actually work because only the plus should have been considered. So we didn't do anything wrong. We just have to know to check these answers. So anytime you have to square something throughout a problem, really any kind of radical here, any kind of square root, you're going to want to check. Well, we didn't on the last problem. Let's take a look back. We really should have, but this one comes out as root 50 minus 1 is 49, minus 6 equals 1. That's 7 minus 6. That does check. Always check your answers. Squaring both sides can possibly give you extraneous solutions. It doesn't have to. Okay. All right, so let's go with, what about cube roots? Well, square root, we squared both sides. This is isolated already. Cube roots, we're going to cube both sides. So we can cube, get rid of a cube root. That's x minus 6 equals, cube that, we get 8. X equals 14. Okay. If you plug in, 14 minus 6 is 8. Cube root is 2. Now, did we need to check this one? Cubing both sides, if you think of x cubed, that is a 1-to-1 function. So this one doesn't actually introduce extraneous solutions. It's the even powers that do. Okay. Now, you can always check your work. It's a good idea, especially on a simple equation like this. Quick, plug it back in, make sure it works. Okay. But you don't have to check every problem if you considered things right. It's a lot of the evens. This is another even-odd difference. So even exponents check. Odd exponents, don't have to worry about. Okay, but go ahead and check anyway for simple ones. Now that gets a little more complicated with something like this. X to the 2/3 equals 9. There is one step we can do that takes care of this, and that's what we want to get at here. The last one we had a cube root and we cubed. We're going to see how that applies with this situation, 2/3. One way to think through this, kind of the long way, is this 2 means x squared, where the 3 down here means cube root. And we could say that equals 9. That means the same thing. So you could get rid of these one step at a time. Like instead of cube root, we could cube both sides. So we end up with x squared equals 9 cubed. Okay. Now that 9 cubed, 729, something like that, is what we end up with. Okay, a little bit bigger number, but then we can get rid of the squared by square rooting. Now, a square root, we do need a plus or minus. Square roots, we got both. And how do we do square root of 729? Well, remember, what we're really doing is this, 9 cubed and square root, and you get to do either one first. Square root of 9 is 3, and that cubed is 27. So maybe we should have got rid of the squared first. They're both part of the exponent, so we can do it in either order. Well, there's a better way to do that. So x cubed, or x to the 2/3, equals 9. Remember what we want. We want x equals, which means x to the first. Well, we know this property that says a to the m power raised to the n power is when we multiply those powers, a to the mn. What if I could find a power that we could put up here and multiply, and we end up with 1? You know a definition of that. Numbers that multiply to be 1 are reciprocals. 2/3 times 3/2 is 1. So we just have to apply that to each side. So the whole idea here is we're going to use the reciprocal exponent. Now that works best when we have something like a fraction here. On the last problem, we had cube root, which is really a 1/3 exponent. So we cubed both sides, which is a 3 exponent. Those are reciprocals. It's already worked for us before. So use reciprocal exponents. Now, then you have to know what to do with what's left. 9 to the 3/2. We can't leave that as our answer. You should evaluate this. So that does mean square root from the bottom. That requires a plus or minus. You have to know when that's required. Any square root. And then 9, and we're going to cube. Do which one you want first. I like the square root of 9. Makes it smaller. 3. And then we cube. 3 cubed is 27, so we have plus or minus 27, which I forgot to write down over here. We had it in the step above. So use that reciprocal power, then just think through what those powers mean on the number you're given. That's kind of the one quick step you can use to get rid of any exponent. All right, so what about this? This goes back to that pure quadratic. Here's this piece we want to isolate. So isolate the important stuff first, x plus 2 to the 2/3. Let's just get rid of the easy things, add 9. If it's in parentheses, it stays together till the end. We just want to get rid of the power, and 2/3, we need 3/2, like we just did on the other one. 3/2, the reciprocal power. So we're still going to isolate, just like we did with the squared. Now we're going to use the reciprocal power, and we end up with x plus 2. That's the first power. They cancel each other out. Equals 9 to the 3/2. So we have a 9. We are going to square root it, which requires plus and minus. That's the square root. 3 is cubed. We just did that a couple times. That's plus or minus 27 is x plus 2. We just have one more step. So subtract 2. So we have plus or minus 27 minus 2. Now this is two answers. Don't leave it this way. This just means 27 minus 2, and we get 25. And negative 27 minus 2. It's not plus or minus 25. This is negative 29. So those are the two answers. Okay, not just plus or minus your final answer, but plus or minus 27. So positive 27 minus 2, negative 27 minus 2. You can check these if you want. You don't really need to. We did square roots. We didn't square. So we did have to remember the plus or minus. So an even denominator is what gets us that, because that's the even root. Okay. All right, what about this now? More fractions and everything. So this goes back to the one we did at the beginning. It's a couple things you should be looking at. First of all, 1, 2, 3 terms. It's a trinomial. With trinomials, we liked them if they were quadratics to factor. Well, let's take a look. On that first one, we had a 6 and a 3 exponent. We said the pattern is double. Look for a 2-to-1 ratio in the exponents. Let's see, here's 3. Here's 3/2. You know what? 3 is double 3/2. That ratio is double, 2-to-1. Okay, that means we will be able to factor. That's what we're looking for. So it's not just for whole numbers. These rules work for everything. Okay, that's what's good about math. So we could have x minus 27, x plus 1, but instead use the middle term, 3 halves. So as long as it fits that pattern, that 2-to-1 ratio, you can treat it like a quadratic. And remember, factoring makes smaller equations. X to the 3 halves equals 27 here, and x to the 3 halves equals -1. Okay, solve. 3 halves, reciprocal 2/3. So x is, let's see what happens to our 27. We have a cube root. Do we need a plus or minus for a cube root? No. So cube root 27, and the 2 is a squared, so do it in the order that you want. I like to root first because that gets us smaller numbers. This is 3 squared, so x equals 9. Now over here, do the same thing. So 2/3 power. X to the first equals -1. We have to do a cube root and then square it. I put an extra little parentheses in there. So get rid of that. Do the one you want first. Cube root of -1 is -1, so -1 squared is 1, right? Now, there's something we didn't see on this that's a big clue, though. This over 2 up here, remember that means square root. When we had square roots in other problems, we solved by squaring, and we got extraneous solutions. You do always want to check your answer. We squared things here. So check your answers. Now, these might be a little bit harder to check. That is. Okay, so checking it, the 1 is easy to check. Plug it in the original. 1 cubed is 1 minus 26 times 1 minus 27. Is that 0? That is not 0. That is extraneous. The 9 does work. Okay, 9 cubed is a 729 minus 26 times 9 to the 3 halves. That'll be 3 cubed is 27 minus 26 times 27 minus another 27. That is a good answer on this one. We should have been able to tell that earlier here, and here's what you can notice to save yourself some time. This step right here, that said x to the 3 halves equals -1. This half is a square root. The square root of something, x cubed, is -1. A square root is always positive. You can't get a negative answer out of that. That's where we should have known that one will not have a solution. A square root answer cannot be a negative value. Okay? All right, next, 8. Back to fractions. 2 more problems left here, getting trickier. Solve for real roots, give exact answers. So we're back to these fractions again that we started with here. And what we want to do first is, again, clear fractions. Okay? And that means multiply by least common denominator. We're going to build this since we have polynomials down here. So this is the same as what we did with complex fractions. Each one I want to cancel, I'm going to make sure I multiply. So if I want to cancel the first fraction, x minus 1, I'm going to multiply by x minus 1 through everything. Okay, so that would get rid of the first one. We've got to multiply by x minus 1 and times x minus 1. Make sure we distribute it through. Next one, that'll take care of the first fraction. Next one, we have to get rid of x plus 3. That means I have to multiply by x plus 3. We'll do that on everything. X plus 3 and x plus 3. We're just building this common denominator. That takes care of the first fraction, took care of the second fraction. What about this third one? I could multiply by x squared plus 2x minus 3, but let's factor first. That is x plus 3 times x minus 1. Well, that's good news. Both of those are already there to cancel. Build it out of the factors you see. Just factor everything first to find them. Now we can see what happens out of this. This first fraction, the x minus 1's cancel. And we are left with 2 times x plus 3. 2 times the other piece it didn't have. Next one, minus x on top. The x plus 3 cancels. We multiply by x minus 1. So build the common denominator, multiply by all the separate pieces, cancel part of it out so you don't have fractions anymore. If you still have fractions after this, you did something wrong. Our goal is to get rid of fractions. Next one, let's see, x plus 3 gone, x minus 1 gone. We're just left with 6 over there. Look how easy that problem looks. Multiply by a common denominator to get rid of all fractions. This is just 2x plus 6 minus x squared plus x equals 6. It's got an x squared and an x, it's quadratic, so let's get everything to one side. I like the x squared to be positive, you should too. Minus 3x, we've removed it over. Subtract the 6 and that's gone. Here's our little factor again, x minus 3. So x equals 0 and 3. All right, 0 and 3 we do need to check on this one as well, but it's simpler. The problem is we multiplied by variables, so that could bring in extra solutions, okay? Notice we multiplied by an x squared. So check, what we're going to check is the domain. We don't need to plug it into the entire equation. We should be able to tell up here the domain, the denominator, tells us we cannot divide by 0, so x cannot be 1, and it cannot be negative 3 from our two factors. Okay, as long as I don't get those answers, we're good. Let's see, we got a 0, which isn't a domain restriction. We got a positive 3, which is good. So both those are okay. So check the domain means check denominators. Okay, really, you can do that right away. Right when you see this problem, as long as I don't get a 1 or a negative 3, I'm good. Then we solve it. We didn't get those. We have two solutions here. So watch out for restrictions on the denominators. You can't have those as answers. All right, last one, number 9. This one looks a little bit different here, but we've done some like this. Okay, we have 1/2 powers. We have a negative 1/2 power. Now, powers are actually easier to use than writing these as radicals. This first one would be a radical square root x, and you can see how messy this gets if we write it that way. This would be 3, and then over, because the negative root x equals 0. There's some things we could do with that, okay? But depending on the fractions that we have up here, positives and negatives, it can get really messy. So this one has two terms, remember. Well, look what they have in common. They both have an x. We can factor this. X to the 1/2, factor it out. And what do we have left? We have a 1 plus, we've done this before. We took out the, all right, x to the 1/2. I shouldn't have taken that out. What's the rule? Don't take out x to the 1/2. X the lower exponent, negative 1/2. So what we're really left with here is x to the 1/2, take away negative 1/2, that's x to the first. Plus, here the x to the negative 1/2 is gone, and we just have 3. So lower exponent always, and that one is 1 bigger. So we end up with here x equals negative 3. Okay. And over here we have x to the negative 1/2 equals 0. So let's think about what that means. That is 1 over root x equals 0. I don't like the fraction, so multiply and we get 1 equals 0. There's no solutions there. So we have negative 3, but we have to check. Remember how we said before this is really root x? Just like the last problem, there is a domain issue here. So the domain for root x, and this one's even a fraction, how we wrote it over here. We know we cannot have x equal 0 in the denominator, so I would say x cannot equal 0. If you see a negative fraction, think about denominators. Also for root x, x has to be greater than or equal to 0. Well, we can't have equal to, so we'll take it out. So our domain on this one is x's have to be greater than 0 to be allowed in this equation. We already didn't have a solution out here. Negative 3, that's not bigger than 0. That is extraneous. There are no solutions on this problem. Always check the domain of the original problem. Okay? We didn't do anything wrong solving it. Just need to check the domain. Now, because these are square roots, some of these are a little bit easier, like this one. Maybe we can take this root x equals negative 3 over root x, subtract it, and multiply here, x equals negative 3. Looks good. But square rooting, I can't square root a negative, so the same problem comes up. There's several different ways we could think through some of these problems. So always check domains for fractions and radicals. Check for extraneous solutions, especially when you square both sides, when you do a non-one-to-one function, really. And if you're always checking your answers, that's good. But go through this and see all the different strategies we use for exponents, for quadratics, for radicals. Watch the details on this. That is what solving is all about, getting all those details in the correct order. All right, use that to help you. Come back, rewatch it for certain problems if you need. So that is the idea on 2-1. That one's easier, and then 2-2 has some of these harder problems on it. All right, that's what you have, just 2-1 and 2-2 for these remote days. Should be good to do in your 2 remote days for 2 assignments and not have to do anything over fall break. All right, guys, I will see you after fall break. Have a good one.